Assalamualaikum, my name is Faraz Iqbal and today I am going to present a review on a paper with a name titled Forensic Study of IMO Call and Chat Application. The said paper is published in 2018 and the authors are M.A.K Sudozai, Shahzad Saleem, Willian Nisar and Haleemah Zia. Here is the presentation sequence. We start from the brief about the paper. Then we go for the device forensic of IMO for both Android and iOS version. Here we study for the analysis of IMO methodology adopted in that paper to extract the IMO functionality. We go for the experimental setup on Android and iOS, study the devices softwares used to conduct that research for mobile forensics. And finally in that portion we go for the result and analysis to extract the file structure, folders and tables from IMO application. The second portion of that research covers the network forensics. Here in that portion we study the devices and software used for experimental setup with respect to network forensics. Also here we study the results and their analysis while utilizing the Wireshark terminal. The last portion is the conclusion. This research paper is based on the analysis of IMO application. IMO is widely used as social media application for free messaging, voice and video call and sharing purposes. The research is carried on the IMO 9.8 for Android device and 7.055 for iOS device. Problem statement. The research is based on mobile forensic and network forensics. Major contribution of this research is carried out categorically in three portions. Artifacts collected from the mobile device, that falls in device forensic. Artifacts collected through usage over network, that falls in network forensics. Investigation of both Android and iOS device is also a part of that research. It is to be noted that communication between IMO clients and server is encrypted. However, all the stored IMO chats, voice, video are in plain text within the mobile device. Device forensic of IMO. The analysis methodology approached in that research for extracting the functionality of IMO on Android and iOS. As we know that the researchers are with the assumption that both the Android and iOS mobiles are rooted by default. So the first step in that research was taken is to install the application and then make the comparison to previous known state before the installation of that application and the analysis of change in file structure after the application installation. The second step is the account configuration, and after account configuration determine the impact of change and locations and the analysis of files and contents. And the third step, we have to experiment for IMO functionalities, and for that we have to perform activities for different scenarios, identify corresponding file locations for each activity, and finally the comparative analysis to previous known state. We have also to find the artifacts locations, formats and contents, and finally we have to go for the result in order to extract and analyze the information. In this slide, we discuss the devices and software used during the experimental setup on rooted Android mobile. The research is based on the assumption that the Samsung Galaxy 6 mobile which we are using is by default rooted, and we have to install a fresh installation of IMO application. We also need a PC workstation along with certain softwares. PC workstation we do require for connectivity to access a smartphone file structure and analysis. We need the Android debug bridge tool in order to get the access of mobile memory. We also need the Android back extractor and DB browser for SQLite to analyze the content of storage elements against each user activity. Results and analysis. Upon installation of IMO on Android, there are three main folders created in the file structure of IMO mentioned here. Let's start with the first one folder. The file structure of folder 1, that is com.imo.android.imo.im-1 at location data add. It is basically created in device memory, and the location is inside data. We have the app folder inside it. This folder is created. and the file created inside that folder are basically the IMO application APK basic and associated files. Storage folder is A. At the right side we can see the pictorial information of that folder. File structure of folder 2. Name of that folder is com.imo.android.imo im at location data. This is a very crucial folder. It stores user related artifacts like likewise credentials and the activities user do perform. This folder is created inside the device memory and the location is data and the folder name. Inside that folder we have a creation of few other folders like cache, databases and files. Inside the databases folder we have 4 DBs and information from those DBs can be easily extractable through SQLite software. Inside the files we have audio folder, we have the video folder, and we have an important file faster ip.json. So here in this slide we have a pictorial display of file structure of folder 2. We can see the red underlines. We have main folder, then inside that folder we have the cache folder, we have the databases folder, and we have the files folder inside. And to your right, just the arrow reflects the inside of the files folder. We have a faster ip.json, audio, and then the video. Similarly, we have a data inside of the databases folder. We have 4 DBs exist. Again in this slide we have the inside of the imofriends.db tables pictorial view. We have seen here we have a total 20 tables. Few are already underlined by red color like calls only, call time stamps, like IMO phone book. At your right you can see that IMO phone book which shows the phone contact numbers of users, and then incoming calls, outgoing calls. We have the incoming SMS, outgoing SMS. So this is basically the imofriends.db database which keeps 20 tables. Huge, a lot of information can be extractable from that DB. File structure of folder 3 named IMO at location data/media/0. This is a location of SD card or user accessible memory that is normally visible through USB connectivity on a PC, as shown in the picture at your right. Devices and software used during the experimental setup on jailbroken iOS mobile. Here in this slide we will just study that the Apple iPhone 5 has been taken for the experimental basis with the assumption that it is already jailbroken and having the version of 9.3. Now we have go and just make the fresh installation of IMO application onto it. Few softwares we do require. For instance, Cydia is required in order to access the file structure and files of mobile for analysis. Similarly, Apple File Conduit 2 is also required for the side activity. We need the PC workstation with the Ubuntu OS terminal, and it is required for the connectivity of mobile phone for the connectivity to access smartphone file structure and files for analysis. Here in this slide we see the pictorial display of the file structure of IMO on iOS platform. We can see here the caches folder, the default folder which keeps the profile images and shared images. We have the lib cache which keeps the captured images. We have the videos, we have DBs. So the entire structure is visible here for iOS platform. Here in this slide we can see the difference of records in IMO tables for Android and iOS platforms. We see the difference in the messages of Android and then messages table in iOS. Similarly, we have total number of tables are 20 in the Android at our left bottom, whereas in the iOS we have only 6 tables at the right bottom. Devices and software used during experimental setup with respect to network forensics. So the researcher established a network infrastructure In order to intercept the network traffic, the target mobile device was connected to the internet through a wireless access point as shown in the picture, and all the internet traffic of wireless access point was routed through a firewall. The firewall was configured to filter out internet traffic and thus help to focus only on the IMO traffic in a controlled environment. The network side of the firewall traffic was mirrored on layer 3 switch for live interception. The mirror traffic was fed to our analysis setup. Our analysis setup comprised of widely used network protocol analyzer Wireshark. Network forensics. Network forensics of IMO application is the second problem domain of author's study, thus characterized by following fundamental facts. The communication protocol between IMO client to its server is not known. All sessions between IMO client and IMO servers are encrypted. Alternative mechanisms of connectivity are not known. To bring out important artifacts of IMO app, authors used a combination of techniques such as port-based analysis, inspection of bytes exchange between the client and server, behavior analysis in a controlled force network environment by means of firewall. Firewall is used to filter out internet traffic only for the IMO traffic in a controlled environment. In addition, with the intention to avoid service non-availability, including traffic monitoring blocking solutions deployed at network nodes or other causes of network failure. In this slide, we see the pictorial display of network forensics results and their analysis with the help of Wireshark terminal. Through research, it has been identified that the IMO traffic uses the standard TCP ports 5222, 223, 5228 and SSL, and the same is highlighted here through yellow box. Here we have in the second picture, when a user A is typing, then a packet with a fixed TCP payload of 160 and 48 bytes were transferred in between user A to IMO server. Similarly, when user B is typing something, then a payload of 144 and 64 transmitted in between IMO server and user A. Again, in this slide, network forensic results and analysis is continue. So we can see another traffic pattern of IMO traffic for call initiating from one target mobile. We see user A initiated a call to consecutive packets payload size of 272 and 128 bytes respectively were sent to server for establishing a call. Here displayed as in red square. In response, the IMO server acknowledged with a packet of 48 bytes in length, again showed displayed in a red square box. Similarly, call initiated from another target. User B initiated a call to packet payload size of 112 and 64 bytes respectively were transmitted in between IMO server and user A, as mentioned in yellow boxes. Afterwards, two consecutive packets payload sizes of 64 bytes and 176 bytes respectively transmitted from target mobile. In response, IMO server acknowledged with a packet of 48 bytes in length. So basically, what is researched through that pick by the authors, that rather than to decrypt the traffic, they on the basis of length of the packet recognized the application's functionality, and that is described in their research for network forensics. In this slide, we discuss the conclusion with respect to the research paper. So the research is conducted with respect to mobile forensic and network forensics on IMO application. Studied and become able to access the databases maintained by IMO app in mobile devices, iOS and Android. All useful information about user was found in unencrypted form. That includes phone book entries, email IDs, call logs, chat box, and even the content of the chats could be easily extracted from a mobile during the investigation of IMO. Studied network traffic of IMO extensively and drew significant results for correct traffic detection of IMO. New idea of using the firewall in such studies was demonstrated that supported research methodology to reveal obscured chats, voice and video call connectivity scenarios of IMO. Different characteristics of IMO network traffic for Android and iOS were also highlighted in this research work.